Good morning, seventh graders. We are going to continue working through the distributive property and combining like terms. So we'll be simplifying algebraic expressions by doing both of those things. And then we're also going to look at some problems where we might need to distribute more than once. So as a reminder, an algebraic expression is in simplest form when two things are true. Number one, you have no parentheses. And number two, you have no like terms. So a like term means terms that have the same variable raised to the same power. So your first step is to clear any parentheses. So we have negative 7a plus 6, and then remember this is 6 times the quantity 6 minus 8a. So even though I have this negative 7a, he's just going to hang out for right now. All right, and then the 6 is actually what's going to be multiplied, this positive 6. So if you think of the order of operations, we would multiply before we would do any addition. So I want to multiply out the 6. And when I'm distributing it, it's like I'm passing it out to each term inside the parentheses. So positive 6 times 6 is positive 36. And positive 6 times negative 8a. So we're looking at the plus and minuses to help us determine if it's positive or negative. So positive 6 times negative 8a is negative 48a. So we've cleared our parentheses. So now I want to look for any like terms. So when I look here, I notice that we have negative 7a, and I notice I have negative 48a. And I know that those can be combined. So this would be a point where like maybe some of you want to still be collecting your terms in like little buckets, if you will. So I can put those a's together, and then I can put my positive 36 as a constant in the other one. Some of you might not need to do that step. Okay, so I look at negative 7a and negative 48a, and I know that's going to give me negative 55a. And then that positive 36, because it's positive, I'm going to write that as plus 36. And so when I look at this, I have no parentheses, I have no like terms left. That's the simplest form for that algebraic expression. All right, when we look at this example, we actually have two sets of parentheses here, so we're actually going to be distributing twice, okay? And so, again, my first step is to clear out those parentheses using the distributive property. So this is 3 times the quantity k plus 10 plus 5 times the quantity 3k plus 9. So my 3 is going to get distributed to everything inside the first set of parentheses. A couple things that we want to remember. We want to remember that this k has an invisible coefficient of 1 right now. And then again, we also want to pay attention to those signs on those numbers. So the plus and the minus helps us determine if it's positive or negative. So 3 times 1k would give me 3k. 3 times positive 10 gives me a positive 30. So this part, I've distributed out that 3. I've passed the 3 out to both other terms. And so now I'm going to move on to the next part. So when I look at what I'm distributing on the next set of parentheses, again, I'm going to look at this plus sign to help me know that this is a positive 5. And so I'm going to distribute positive 5 times 3k, which gives me positive 15k. And positive 5 times positive 9 is positive 45. So we're going to ask ourselves, do we have any parentheses? Nope, we got rid of those. And now we're going to ask ourselves if we have any like terms. And I do see some like terms here. So I see a positive 3k and a positive 15k that I can combine. So we're going to go ahead and combine those, and 3k plus 15k would give us 18k. Now I also see constants. I see a positive 30 and a positive 45. So positive 30 and positive 45 combine to be positive 75. Because it's positive, I can write this as a plus 75. So now I'm going to ask myself, do I have any parentheses? Nope. Do I have any like terms? Nope. So this is in simplest form. On this particular problem we're going to look at, we have those two sets of parentheses. So we're going to be distributing twice, but we also have some negatives that we're going to need to pay attention to. So again, the negatives or the minus signs tell us that those terms are negative. So on the first set of parentheses, I'm distributing a -4 to everything inside the parentheses. So -4 times 6 is going to be -24. And then -4 times positive 8n is going to be -32n. So the 4 times 8n is 32n. Because it's -4 times positive 8n, that gives me a -32n. On the second set of parentheses, I'm distributing a positive 8. So I have positive 8 times -8 is -64. And positive 8 times positive 2n is positive 16n. I'm going to look for like terms. So again, we can ask ourselves, do I have any parentheses? Nope, I've cleared out my parentheses. That's the very first step you always want to do. My next step is to combine any like terms. So when I look at this, I see I have -32n and positive 16n. Which combine to be -16n. And when I look at my constants, my numbers without my variables, I see a -24 and a -64. So I'm going to put those two together. I know that -24 and -64 will equal -88. And so to write my final expression, I get -16n. Because the 88 is negative, I can write that as subtraction. So -88. I'm going to ask myself, do I have any parentheses? Nope. Do I have any like terms? Nope. There's my simplest form. On this one, same idea. We're going to be distributing. We have some negatives to pay attention to. So I have -5 times 8b would be -40b. -5 times positive 10 is -50. Over here, I'm distributing a -10, so I want to make sure I pay attention to that. Because this is -10 times the quantity 3b plus 5. I'm distributing a -10. So -10 times 3b is -30v. -10 times positive 5 is -50. I'm going to look for like terms. I see -40b and -30v. I know that those will give me -70v. I also see some constants. I see -50 and -50, which I know will give me -100. I can write that as -100 because it's negative. So do I have any like terms? Or sorry, do I have any parentheses? No. Do I have any like terms? No. So that's in simplest form. Okay, now when we get to a problem like this, I have my two sets of parentheses. Now this one looks a little different because I don't technically have a number out in front of either one of these, it looks like right now. Okay, so when we see a problem like this, we want to keep in mind, similar to what we know about our variables, if we see a lone variable by itself, there's an invisible 1 as a coefficient. That's also going to be true for both of these examples. So this is like an invisible 1 that I'm going to be distributing. And then on the second set of parentheses, if I put that invisible 1 there, I want to view that now as a -1 that gets distributed. Okay, so when I multiply this out, 1 times 1y is just going to be 1y. 1 times positive 9 is positive 9. So I've cleared out my parentheses. It looks very, very similar, but I've just cleared those parentheses. All right, and then now I need to take this -1 and distribute to both of these terms and also pay attention to my signs. So a -1 times a positive 3 is negative 3. Negative 1 times negative 4y would be a positive 4y. From here, I'm going to look for like terms. So I see some y terms. I see a positive 1y and a positive 4y. I know that those together will combine to be 5y. When I look at my constants, those numbers without the variables, I see a positive 9 and a negative 3. So positive 9 and negative 3 gives me positive 6. So I can write that as adding 6. When I read 5y plus 6, do I have any parentheses? No. Do I have any like terms? No. So this is in simplest form. Here's another example where over here on the first set of parentheses, we have a number we're going to distribute. On the second set, this minus and then the parentheses, there's no number right here right now. So we're going to draw in that invisible 1. And again, because that's a subtraction sign, view that as a negative 1 to distribute. So we have positive 3 times 2m would give me 6m. Positive 3 times 2 gives me a positive 6. Over here, negative 1 times 5 gives me negative 5, so I write that as subtraction. And then negative 1 times negative 6m, and negative times a negative gives me a positive, so positive 6m. I'm going to look for like terms. I see 6m and positive 6m. And so I know that those will combine to be 12m. And then I also see constants. I see a positive 6 and a negative 5. So positive 6 and negative 5 will give me positive 1. Do I have any parentheses? No. Do I have any like terms left? No. So 12m plus 1 would be my final solution there. This one looks a little bit different. It says write a simplified algebraic expression to represent the perimeter of the triangle. Perimeter is the distance around a shape. So imagine either running around the triangle, okay, if you had to run around the entire shape, or you could also think of building a fence around that entire shape. Whichever way you think of it, to find the perimeter, we need to add up all of our sides. So what that means is I want to add up. My first side is 5x minus 2. So if I add that side, now with another side, I have 2x plus 5. And then my third side is the plus 3x. And so from here, this is where I would look for like terms. So this expression right now, this algebraic expression, is representing the perimeter. I don't know what x equals. I don't know what the perimeter equals. Can't do anything else as far as like solving necessarily, but I can simplify this expression. So right now I'm just showing that I've added up my 3 side lengths. So when I look for like terms, I see a positive 5x, a positive 2x, and a positive 3x. And so if I add those all together, I would get 5x plus 2x is 7x plus 3x is going to be 10x. And then when I look at my constants, I see a negative 2 and a positive 5. Negative 2 plus 5 gives me a positive 3. Do I have any parentheses? No. Do I have any like terms? No. 10x